Welcome to my shop. So what do we got going on here? Well, I'm hoping I can get some input from my viewers on this one. So, if you follow my channel, not many people do, but if you do, and you remember a video I made about a year and a half ago, where I talked about the furnace that came with this house, you might remember this. So, this house was built in 1954, and it still had the original furnace when I bought it in 2018, November of 18. The furnace was about 25% or so larger than this guy here. You can see the footprint still, it's quite massive. You can actually see the rust marks where it was. Anyway, that was an oil-fired forced hot air furnace, and this was the oil burner. And to be honest, there's not really a lot on this burner that is original. Pretty much everything has been replaced at least once. The oil pump, the motor. I actually put that motor in. That was when I bought the house. It had a replacement motor on it, and that was shot to hell. So I put a new one on to keep it going for at least the first winter. And then in the spring, I bought that, had that put in. But the point is, it was still a functioning burner when it was pulled in the spring of 2019. So why is it still here? Why didn't it go? Why didn't it go out to the junkyard with the rest of the furnace? Well, it's just too beautiful to throw away. I mean, look at this thing. It is absolutely gorgeous. It really is. It's just a beautiful piece of machinery, and I felt that I could do something with this. And that's where you guys come in. What should I do with it? Now, getting it running again wouldn't take much at all. I need to replace the oil line from the pump to the gun, or the nozzle. And so that's no good. The oil line actually cracked when I was replacing the nozzle in this thing, and I ended up cracking the oil line in the process. I went to go turn this nut here, this fitting, and the line twisted, and once that happens, it's game over. But the good news, it's just a 1/4 inch copper line, and it uses crushed fittings. So that'll be an easy fix. The pump, I actually took the pump apart to take a look inside, and I was just curious to see, how it was constructed. And it's just a rotary vane pump. I'll actually take it off. I didn't thread these. I didn't tighten these down. So we'll take a quick look at it. There's a strainer inside here. Whenever you service the burner, you're supposed to change out the strainer in here anyway. So this is just part of normal maintenance. But I actually took the rotor out just to see. I hadn't really planned on doing anything with this unit at that point. Let's take a look inside here. Look at that. Look at that strainer. Oh my God. That strainer is NFG. You know what that means. But you can see, I believe this whole thing rotates with the motor. Or it's actually inside here. Wow, it's been a while since I've had this apart. I forgot how bad this was. Oh my God. You can't even see light through it. Look at that. Look at how clogged that is. Anyway, that's how it was running. So maybe we order a new strainer and a gasket for it. I think I can still get those. But, the other repair it needs is, this is the base that it mounts on, and it needs to be welded. The way the gun was installed in the furnace, you're supposed to loosen this threaded rod and drop the unit down so you could pull the base up over the lip, but well, somebody felt they were above that and they cracked the damn thing. Look at it. Anyway, I'm going to run that over to my parents' house. My dad's got an arc welder. I can just tack it and fix it. No worries. So yeah, we need to get a new screen for this Sunstrand pump. I might just try to find another pump. I mean, what the hell, right? No, I don't want to put any money into it. The paint on this thing is immaculate. It's really good paint. It's original from 1954 paint right there. Manufacturer, it's a Quiet Heat Model A. And, you know, these style oil burners were actually, they were the first consumer oil burners. They were the very first ones. Well, one of the first ones. This design dates back to the 1930s, if I recall, and they pretty much kept the same product, or the same unit in production under various brand names for about 20 to 30 years, at least 20 years. So, and if you compare it to a modern oil burner, which is only a fraction of this size, it's incredible. And this actually predates the retention head design burners that we use today. The retention head burners, or the flame retention burners, they produce a more uniform flame, whereas this just sort of scatters the fire all over the place. It's not a very good looking flame. It's just little licks of flame shooting everywhere. It's quite unnerving to see. Anyway. I mean, I mean, look at this thing. Now, as far as componentry goes, I mean, it uses a modern nozzle. I mean, this is a brand new nozzle. I bought this with the plans of actually bringing it back to life and using it in the house. Like, I hadn't really decided to replace the furnace at that point. It wasn't until when I took this thing out of the furnace in the springtime to do some service to it, I looked inside the firebox, and then I looked up at the heat exchanger, and that's when I made my decision to replace the whole unit. The firebox, the fire brick, which appeared to be asbestos rather than a modern fire brick material, it looked like it was actually made of asbestos blocks, and they were crumbling. And the heat exchanger, well, not cracked or anything. Actually, the heat exchanger was in remarkable condition for something that's 66 years old. But it was so clogged up with flaky material. I was just, you know what, let's just get rid of it. You know, I had the money in the bank to replace the whole unit. I'm like, let's just do that. And that was a smart move because I spent about half as much money in oil for last winter than I did the winter previously. Efficiency is not the strong point of the 1950s oil burner. Let me just get that out of the way. But check out the size of the ignition module. Check this thing out. Now, I want to energize this, and we can make some pretty cool sparks. This thing puts out, I believe, 10,000 volts. Primary winding, 120 volts in. Secondary winding, 10,000 volts out. Yeah. This thing puts out the juice. Actually, I think the newer ones put out like a lot more than that. But 10,000 volts gives you a nice steady arc between those two probe electrodes. The original, the previous electrodes that came in it are over here. Here's the oil line. Yeah, this is the oil line that got damaged. I bent it. What the heck? Oh boy. Wow. That was not planned. But here are the electrodes. They're not in bad shape. I'm going to clean these up, put them back in. So I actually bought new electrodes, but I bought the wrong ones. It turns out that Sid Harvey or Sid Meier or whatever, they had they had listed the wrong electrodes for this burner, and I bought those, and they don't fit. So we're going to put these guys back in. They do fit, and they still work. We'll just clean them up with the bench grinder. As long as the ceramic isn't cracked, they're still good. And yeah, they're not worn beyond belief. We'll just clean them up, put them back in. Let's get a good look inside here. And you can see it looks like a modern, basically from this point forward, it's no different from the brand new burner that I had put in. It's the same thing, same parts, really. But what it lacks is a retention head. And I mean, you know, as far as controlling this, really, you know, oil pumps or oil burners are very simple in their operation. I mean, all they do is when you apply power to this thing, it spins up this motor over here, which rotates a shaft that goes through the unit. And this is just like the one you buy from a plumbing supply company today or a heating supply company today. Brand new units off the showroom floor. Same exact concept. You've got a motor that drives a shaft, which drives an impeller in the middle, or a squirrel cage blower, and it rotates the pump on the other end of the unit. So what this is doing is it's pulling in air from this area here. This is your air intake, and you adjust your airflow by rotating this band and closing off the shutters. So you got, if you have too much air, you close it down. You have not enough, you open it up, and use a combustion analyzer and visual inspection of the flame to determine, and your smoke pump to determine whether or not you have the correct amount of air for the combustion process. But it spins the blower and the pump. The blower forces air into the combustion chamber. That air swirls around through these vanes here. These vanes are what give the air kind of a swirl pattern, and that's supposed to keep the flame somewhat uniform and provide it with enough oxygen for combustion. And the pump draws fuel from the tank, which is that big thing over there. It draws fuel right from the tank, and it forces it under about 100 pounds per square inch through this tube here, through here, down a tube in the middle of this nozzle in the middle here, through that nozzle right there, and it atomizes it. This nozzle will atomize the fuel into a fine mist. And as for ignition, for the first, well, until it reaches a certain temperature, or until well, this one, all right, so I'm going to backtrack a bit. This unit did not have any real safety controls other than what they call a stack switch, and I'll get to that in a minute. Modern guns use a electronic eye to determine whether or not combustion has succeeded or not. Now, in a furnace like this, it provides 10,000 volts of electricity from this coil here, which causes these two electrodes to arc. There's a steady arc between these two, and you'll actually hear an audible buzzing sound upon startup. Now, in a modern furnace, once the electronic eye sees a flame, and I believe it also uses temperature to determine whether or not it's okay to shut off the ignition source, because the ignition source doesn't stay energized. Once ignition is no longer needed, the constant feeding of oil and air keeps the flame rolling. You don't need spark. So on a furnace like this one, it'll use the stack switch, which is basically a temperature probe mounted in the chimney, in the stack. And once it reaches a certain temperature, it says, okay, we no longer need ignition. Now, it'll keep the motor running until the thermostat in the heat exchanger, or I'm sorry, until the thermostat in the house says, I don't want any more heat. We've reached temperature, shut down. So, Are you with me? So, in this unit here, these are dangerous because they don't have that electronic eye that senses, combustion, fail, or success. It waits a little. It is given about maybe a 30-second window or so, or maybe let's say it's shorter than that, like 20 seconds. It's given a certain length of time from the stack switch to decide whether or not it wants to continue. In other words, if combustion does not succeed within that 30-second window, the safety switch in the stack switch unit shuts the unit down for an important reason. If after 30 seconds, and I don't know what the exact time is, but if after 30 seconds, the stack switch senses correct heat from the exhaust, 400 degrees or so. If it senses that 400 degrees, it allows the unit to continue running, and then it defaults to the thermostat operation. That's the household thermostat. If it fails, it'll shut the motor off, and it'll trip out a reset button. The reset button will pop out of the box, and then you have to manually press it down to try to restart it again. Here's where things get dicey. Because these older units will allow 30 seconds worth of unburned oil to be sprayed into the combustion chamber without any ignition at all, because let's say the igniters aren't doing their job. Let's say the ignition source, this thing, burns out. Okay, it'll keep pumping oil in there. Stack switch says, all right, you got 30 seconds. Okay, now you got 20 seconds. Come on, baby, you got 15. It's still pumping oil. Okay, your time is up. Boom. Shuts the motor off. Once the motor shuts off, of course, the pump stops spinning. No more oil. Homeowner says, gee, it's getting cold in this house. Let me see what's going on. Homeowner doesn't know anything about oil furnaces or how they run or how dangerous they can really be. Homeowner says, oh, the stack switch is, it tripped. Oh my God, I better press that button. Okay, here we go. Stack switch says, all right, homeowner wants to give it another go. Here we go. So the burner fires up, sends 120 volts to the motor and the ignition source. Ignition source kicks in. Motor starts spinning. Pump starts spinning. Everything's going. You got oil spraying in. Stack switch says, okay, I guess we're on round 2. Yeah, 30 seconds. 15. 10 seconds. 5 seconds. Okay, you're done. Homeowner says, well, shit. Still no heat. Comes down the stairs. Presses the button again. A third time or a second time. Stack switches, okay. All right, let's do it. Let's try it again. Hey, third time's a charm. And you see that process can continue and continue. In the meantime, there is a fault in the ignition system that the homeowner's not aware of, and the stack switch, because it's just an on-off switch, it doesn't know. All it knows is it's not generating enough heat to continue operation. So, well, now what? Ignition source might be defective. Now, maybe it's intermittent. Maybe you've got a weak transformer in here. It's not enough. It's just on the cusp of failure. Let's say the homeowner comes down after that third failure, presses the switch again, and the transformer has a moment of clarity. I bet you know where I'm going with this. Transformer finally wakes up and says, well, gee, motor's running, I got power, I've got 120 volts, the motor's going, everything's going. Geez, maybe I should do something. Transformer applies just enough power to create an arc between these two igniters. Transformer finally overcomes its grief, sends enough spark there to ignite. What do you think is going to happen next? You've got 90 seconds or more of unburned oil in that combustion chamber, just waiting for an ignition source. In addition to what the pump is feeding the system normally. Kaboom. And that is why these units are so dangerous, because they can cause severe property damage in those instances. What makes this worse and more dangerous than a modern oil burner, it's not in the operation, it's not in the mechanics of it, it's in the control and logic of it. For example, if the burner in this new furnace has an experience like that, a couple of things happen. Well, number one, the electronic eye, it gives it a much shorter window, because the electronic eye is instant feedback. As soon as ignition is realized, that electronic eye says, whoa, we have flame. We don't need ignition anymore, so let's shut off the transformer to save energy, and let's just keep rolling until the thermostat upstairs says, I don't need you anymore. Okay, so that technology has been around since at least the 60s. And that's how old this thing is, 54. They didn't have that. Actually, I think it might be 70s, but you get my point. But it does. Now, let's say the transformer in the new furnace goes bad, as they often do. They're not made like this. This transformer is good for 40 years. New ones, not so much. A new transformer, you might get 5 years out of it, okay? Let's say the transformer in my new furnace starts to flake out, and it fails to ignite. So you have a much, much smaller quantity of oil. It might have maybe 5 seconds worth of oil rather than 30 seconds worth of oil. And I can't tell you how much that is in volume, but you get what I'm saying. So it trips out once. I waddle down the stairs, I open the furnace, and I press the reset button, which is right on the gun. I press the reset button, and it tries again. And let's say maybe it fails again. And then I get impatient. I press the button one more time. It tries and fails. So here's the difference. The modern oil burner is designed to protect the house from the homeowner. It will lock out. It will not let me press it again. It will lock out on safety, and I will have to call somebody with the appropriate equipment to reset it, which means that I'm forced to get the problem fixed correctly rather than dicker around with the reset button and blow my house apart. So that is why these units are so damn dangerous. So if you have an oil burner like this in your home, really keep an eye on it, and really, you can do some damage. So I thought I would use this as an opportunity to try to explain how these things actually function, and they're very simple in operation. Like I said, all it needs is 120 volts to run the motor and the ignition source, and it needs fuel, and it'll run on I believe it's number 2 fuel oil, kerosene. You can convert this to a waste oil burner by changing out the nozzle, but the problem with that is you also have to preheat the fuel. I've looked into this. I thought about using this as a waste oil burner, and you have to preheat the fuel, so that requires more equipment, and it's just not, these aren't built for burning waste oil. Could be done though. I mean, another thing you could do is mix some of that waste oil with kerosene, and maybe you might be able to burn it, but at that point you're just wasting kerosene. So yeah, I'm going to keep this original. I mean, well, it's not original. Everything's been replaced. The pump, the motor, and the ignition source. They've all been replaced at least once. And I put this motor in, and yes, I know there should be something here to protect the wires. But I was in a rush to fix it, and it worked, but it wasn't safe. should probably try to find a new one of these. Look at that. Now, I want to stress it. So this crap is what made it through the oil filter. This made it through the oil filter. This is why you have pump screens on your oil pumps, guys. This is what they're for. I don't have a part number on this. I bet I can find it, though. The new ones, by the way, are like that big. They're not like that. They're like a little. I watched the guy. I had the burner serviced a couple months ago, and I watched the guy do the job, and he had no problem letting me hang over his shoulder. But the filter he put in was like just tiny. It was a gasket filter all in one, I think. Oh man. But it's such a beautiful piece of machinery. I mean, you look at how they styled things back in the 30s when this was designed. It's all Art Deco, but there's a reason for that. Because a lot of the furnaces that were made around that time, they were still burning coal, and there was an option for coal furnace owners to buy an oil burner conversion kit. The oil was really big back then. Oil was cheap, plentiful, and you could buy a kit which included one of these, and it would sit in place of your coal hopper, which sat in front of the furnace, and it would sit on the floor. This is the base. It just sits right on the floor, and you would just kind of stick it right into the opening where the old coal tender would have gone. But it was designed to look presentable because, I mean, everything back then was overstyled. But it was presentable. You could walk down in your basement, you have a game room down there, and the furnace is in the corner, and it doesn't look all industrial, and it's got some nice style to it. You look at some of the old steam boilers and some of the old even octopus furnaces. They all had some style to them, Nowadays, it's just a big gray box because cost is everything. This costs money. It costs money to design this like that, It costs a little more, probably. And that beautiful green paint, it's such a nice shade of paint, green. It's almost like a John Deere green. Anyway, I digress. So, yeah. These were sold as oil conversion burners, but they were also installed as original equipment on forced hot air and oil burner furnaces back in the day. For the record, the furnace that this came out of was a Mayflower. That's who made that. And they went out of business in 1962. So what am I going to do with it? Well, I'm going to gussy it up. I'm going to clean it up a little more. I'm going to do my best. I'm going to clean this up. Maybe take a wire wheel to it or something. And then I'm going to paint this with a heat-resistant, probably silver paint. Engine exhaust manifold paint is what I'm going to use. And I'm going to do that. Put a new oil line on there. I'm going to try to find a filter for this oil pump. I'm not sure if I'm going to have any luck with that. And then we'll put these electrodes back in. But I want to hear from my viewers. What do you think I should do with this? A couple of ideas I've had in my head. I was going to use it for a forge. I wanted to make a forge and mount this maybe on a wheeled cart or a wagon with a small fuel tank, and put and actually cast out of concrete my own combustion chamber. And then I'll buy like a crucible, and we can melt soda cans down and maybe pour them into bars until I learn how to do casting, green sand casting. It's always been something I've wanted to do. But when this thing landed in my lap, I'm like, I could use that for that. Use it as a heat source. I know everybody's doing propane for home forges. Why not do oil? Kerosene, It smells better, It smells better than gas, and but it's very sooty and it's dirtier. But that's besides the point. We're having fun. Screw the dolphins, they say. So that was my idea. I also just thought about making a display piece and putting it in the living room. I've presented the idea to my girlfriend, and she promptly threatened to leave me, so I'm not going to do that. So I got a little ambitious, and I took the nozzle and electrode assembly out, and this is what these old ones looked like. Look at that. It's like a little propeller. And that's what directs the airflow around these vanes, or these blades are what direct the airflow into a swirling pattern around the nozzle here. And like I've mentioned earlier, I mean, the basic principle and some of the parts in this unit, even as old as it is, they look just like those of a modern unit. You know, once they figured it out, they just stuck with a good thing, you know. And this is what it looks like inside the barrel of the gun. And you can see the electrodes, they actually attach to these lugs here. And it's through these little conducting wires that mount to the end of the electrodes. So what I'm going to do is I'm going to go ahead and clean these up on my bench top grinder, and we'll make these look a little better. So what I've figured out is these electrodes aren't the right ones either. It looks to me like the previous technicians who have worked on this unit have, well, I believe these have been in there for a very long time, and it looks like they were just bent into submission so that they would actually fit, but they're not the right ones. And that's kind of interesting because it's pretty obvious that they just didn't have the parts, and they made it work. But these are the ones that were working last. And I'll show you the difference between the new ones and these old ones, and they're just not right. So the ceramic length is right. The biggest problem is the very end of the electrode. It's not the right, see, the electrode tip is fine, the ceramic body is fine, but the end of the electrode is where we have a problem. And I don't think these detach. Maybe they do. Or maybe they do. Maybe alright, maybe we're okay. Maybe we can make this work. That's basically what the electrode looks like internally. Okay. So if I could, if I just unthread, oh yeah, maybe that's how you do it. Maybe that's how you do it. So we just take these guys on that, put that on there like that. Ah, I get it. Okay. So really, we have the right electrodes, but the end is the wrong end. Well, that makes sense. All right. Clean this up, make it look pretty again. Make me look pretty like your French electrodes. Okay, here we go. Clean the body up a little bit there. So yes, there is hope for us after all. And we'll just take this. I should probably do a better job cleaning this. What do you think? I don't know. Maybe later. Now I actually have an electrode guide thingy-majiggy that might help us. Yeah. I'm gonna try something. I've got this orange oil-based paint stripper, and I bet you it would clean this stuff off. What do you think? Let's give it a try. Okay, that's a little better. It's not perfect, but better. Better is better. Better. Okay, let's get our electrodes in here. I'm going to do my best to adjust them. Now, my furnace guy, who did my he corrected all the problems that the installer caused. And the guy who came in after him, he actually showed me how to properly adjust my electrodes. Now I'm going to see if I can do this right. Let's see what we got here. Now, the guides and instructions I have are for a modern day Beckett, but probably the same shit, different day. So, what I have here is a Beckett electrode guide. Now, let's see if I can do this right. So, the nozzle and electrode gap should be this does not apply to a 1954 quiet heat. Let's see. I don't remember what he told me. I just don't. I don't remember what he told me. But it has to be, you know, a certain position above the center of the nozzle. I'm just going to eyeball it and trying to get it as close as I can without going over. Let's see what we can do. Yeah. I mean, yeah. The idea is you definitely want the electrodes to be positioned. You want the arc to occur well within the cone of flame to get it to ignite. So, but we're not going to be lighting this thing off anytime soon. I have far more work to do. Okay, so that's going to do her for now. And what I'm going to do at the end of this video, or before the end of this video, I want to at least energize the coil and see if we can get a good arc out of it. So, where's my my little wires? Here's my little wires. These little wires, they thread into the end of these nipples at the end of the electrodes. They're supposed to thread in. Like that. And that's, again, this is something that you won't see on a modern furnace. That is certain. Now, I want to make sure I get these right because we don't want any, yeah, I think I got this one in the wrong guy here. So we're going to put this one in the one below. It wouldn't hurt to take my wire wheel to these and clean those up too. Actually, that'd be a very good idea. Let's do that. Let's do that. Let's not set ourselves up for failure. It's a little prettier. All right. So what we need to do is figure out which one goes where, because so this assembly sits inside the furnace like this, and one of these has to go to the top lug. One of them goes to the bottom lug, and I'm pretty sure that's how it goes, because it wouldn't make any sense to go that way, right? So that's how she goes. I'm going to thread these in there. So you definitely want, you know, a nice clean contact surface. I don't know how far it goes in, all the way or some of the way, but let's see how that goes. And then this one here. I couldn't imagine. I mean, you're a greenhorn oil burner technician, and you know you get called to this house for a tune-up, and it's like November or something, early in the season, and so you get a call. Oh, this should be easy. Oil furnace in a residential home. You know, you go in. And you see this freaking thing staring you in the face, and you're like, what do I do with that? So you're like, well, and the customer says, I don't want a new furnace because, you know, you're just trying to rip me off. You're just trying to sell me something I don't need. My furnace works fine. Why do I need a new one? And you're like, cause, yeah. Look at how dirty this thing is inside. Oh my lord. If you want to see how a modern oil burner is serviced, check out Steve Lavamonier on YouTube. Yeah, he's a pretty cool guy. He's a New Englander, lives next state down from me, and that's all he does. Is he services, you know, heating equipment and air conditioners. He has a lot of good videos on how, you know, not how, he doesn't do like, you know, here's how you, the consumer, services your furnace. His videos are more directed towards professionals, but, so this thing goes in like that, and then it should slide through this hole here. And then, now this is how you connect the electrodes to the coil. These have little loops on them. We might have to back those off a little bit. I think I've got them in too far, because I can't. All right, that one works. Now this one here doesn't reach, so I'm going to back it out a few turns until it does. There we go. All right. That's basically how it goes together. And I think I dragged the electrode. I didn't tighten it down far enough. Yeah. So it backed out on me. So I got to go back and do it again. So that should be straightforward. Pull this whole thing out here. But when I looked at this house, day one, like first time I looked at it, I just couldn't believe how old this freaking furnace was. I was dumbfounded. I'm like, how the hell is this thing still running? And who let it run this long, first of all? Not only that, but how much is the oil going to cost to fuel this stupid thing? The oil bill was nearly double what it is now when I had this thing going. Absolutely, astoundingly different numbers. I gotta put this back in. I gotta tighten this down a little bit more. I skimmed a little bit on torque. So, yeah, I just could not believe how old this freaking furnace was. And the home inspector, he said, yeah, she's old, but she runs. It's like, I wouldn't want it in my house, but you know, you might be able to get a season or two out of it. So I'm like, well, that's reassuring. You should be about the same depth here. All right, let's try this again. This time, maybe we don't fuck it up. Okay. What a beast, huh? What a beast. Sliding like that. Through the hole. And then you install these nuts here. And there you are. So if we apply 120 volts to that transformer, we should have a sparkage on the other side. Let's give it a shot. Before I plug this in, I want to point out a few things. 1954, the building was constructed with ungrounded electrical throughout. No ground, nowhere, no how. Back then, not everything was polarized like it is now. That was a joke. But back then, they didn't really polarize things like they do these days. So we don't really know which side of this is hot, which side is neutral. that aside, if this unit were to malfunction, the whole furnace was ungrounded. That's the high voltage, that's the motor, that's the whole thing. And it's all made of metal, connected to metal ducts, which are connected to metal registers. You get where I'm going at with this. So if this unit were to have malfunctioned, sending the, God knows, oh, did I do that? Did I seriously just cut off the wrong end of this? Oh my God. Look, all I'm just saying is that there's a, let's say there's a hot ground issue. So the hot side is grounded somehow to the chassis of this blower here, this burner, which is then energizing the ductwork, and then little Susie's in the bathroom on the stool, and she's drinking water from the faucet, and her foot slips and hits the freaking register on the heating, which is next to the sink, by the way. Oh my God. So let's plug it in and see what happens. Now, we don't have the motor energized, we just have the coil. Here we go. See, what's happening here, this is good, I'm glad this happened. So what's happening is we're getting spark, but it's actually going the wrong way. Look at that. Look at that. You can't even see it on the camera. Can you? Look at it. It's like a Jacob's ladder. So there we go. There's our spark. Look at that. Now, if I were to touch that, if I blow on it, it is a Jacob's ladder. So this right here, I'm not going to go too close to it. What we have here is the gap is too far apart. I'm glad this happened. So if the gap is too far apart, what's going to happen is the spark will start to look for other things to jump across. In which case, it's kind of going from the nozzle to the end of the electrode nearby, to the nozzle again, and back and forth and so forth. So that would be a very poor ignition. And that would be an understatement, by the way, actually. That's pretty cool, though. 10,000 volts, guys. If we sprayed anything flammable against that, it would definitely ignite. It smells funny. You can smell the burning ozone. Okay, that should be de-energized, right? Let me make sure. Yeah, okay. It's de-energized. All right. Is it hot? A little warm. It's a little warm. So we got ignition, guys, but we have to adjust those electrodes. Holy shit. That is way off. So that's what happens when your oil furnace's electrodes are misadjusted. That would be the understatement of the century. Though the gap is far too wide, and it's not even. It's arcing against the nozzle, which is not cool, and we don't want that. So let's take it apart here. I'm glad that happened because it gives you a. For those of you who are curious as to what electrodes and why the adjustment or the gap is so critical, is so that it arcs the right way. You know, the arc is not sent in the wrong direction. I can't get this damn thing out. Why is it? It's hanging it up here. Oh, there we go. Okay, so let's get this out of here. Come on. Yeah, it just doesn't want to come out. You got to tilt it just the right way to finesse it. Oh, see this crud right here? We got to clean that out if we're ever to fire this up, because that right there would get right into the nozzle, clog it up immediately. So let's readjust our electrodes. Okay, so now we have closed up that gap a little bit, so we'll have a more predictable arc. All right, here we go. And then, oh yeah, this whole gun assembly is just a little crooked. Yeah, just a wee bit. And what's setting it off kilter is the look at the shit in there, man. That is so dirty. All right, I'm gonna fire it up again. Well, I'm gonna get my hand out of there first. But I'm gonna fire it up again. Yeah, the electrode wires are giving it a little bit of a bias directionally. Here we go. Okay, I can already tell that sounds better, but it still wants to Jacob's ladder itself. Let's turn the light off. Look at that. Ah, yeah, this light here. Turn off, yo. I mean, it works. I want to touch it just because, but I'm not gonna. I'm not stupid. Okay, that was fun. Now, okay, let's get that motor going. Now, I don't want to run the pump because the pump is absolutely dry, and we don't want to risk damaging that pump because I don't have another one. So I got to get my. Here we go. We're going to fire up the motor and see if that still runs. Alright, we yanked the pump off so that we don't damage it in this test. But we'll at least get to see that squirrel cage blower move. Now this right here, this coupler, yeah, that's what attaches, this is a breakable rubber coupler. And what happens is if the pump ever locks up, that coupler will break, allowing the motor to continue to spin, but it won't generate any heat. Here we go. And what you're seeing right now is the air forcing that spark outward. Flowing the wrong direction. Flowing it back this way. But I do feel air coming out this way, so maybe, oh, I know why. Yeah, it's over pressurizing the chamber, so there you go. But aside from the ignition, it's pretty quiet though, isn't it? That's plasma, baby. Don't touch that. Yeah, it should be blowing air. It's definitely blowing air though this way. Absolutely. Nice. And no, you can't heat your home with that. That's not enough heat coming out of there. There you go. Well, we know she runs. All we need now is fuel. Oh my god, this thing is heavy. Holy shit. Give me fuel, give me fire. Give me that which I desire. So once we get a fuel line rigged up, we should be in business. This is the replacement line I scavenged for it. And I just got to get some bubble flares And then we'll get some K1 kerosene and bet we can fire it up. Make some fire. In another video, at another time, on another day. Until then, stay warm. Rather than spend money on a new filter, I think what I'm going to do is spend even less money on a little fuel. We'll just clean it. What do you think? See, the gasoline will wash this whole thing right out. Just let it sit there for a little while and let the gas do its magic. And there you go. That's how you do it. Why pay more? And a penny saved is a penny earned. But look at, look at how clean it is. It looks brand new. Like it never happened. As for the fuel, I'm going to burn it in the lawnmower. What the hell? No worries. Or if I can find a lesser engine to burn it off in. Nah. Burn it in the lawnmower. I'll just filter out the particles and burn it up. There you go. Oh, yeah, okay. That makes sense. That makes sense. And this right here, this is to keep tension on it. These little tabs.